Hello everyone, this is Miss Chelsea and today we'll be learning about phase changes. Our question of the day is what are the 6 phase changes? Our current standard is SC5A, which is to plan and carry out an investigation to calculate the amount of heat absorbed or released by chemical or physical processes. So a phase change is caused by the addition or removal of heat, energy, or pressure. For example, melting is when a solid turns into a liquid. This requires you to add heat. Freezing is the opposite of melting. It's when you go from a liquid to a solid. This would require you to remove heat energy. Then we have vaporization, which is taking a liquid and turning it into a gas or vapor. This requires you to add heat. And its opposite, condensation, will require you to remove heat to go from the gas or vapor stage to a liquid. Now, you can also go directly from solid to vapor by a process called sublimation, which, just like melting and vaporization, requires you to add heat. Deposition, on the other hand, goes from vapor directly to solid by removing heat. Keep in mind that anytime the particles are getting further apart and requiring more energy to move around because they can go further and faster, you need to add heat energy. If they get closer together, they slow down, you remove heat energy. Here's a quick reminder, energy is the ability to do work. It is measured in joules, where joules is a metric unit that can have a prefix attached to it, such as kilo. For example, kilojoules. Now, the average kinetic energy is defined as how fast molecules move. It is directly related to temperature. So hot particles move faster, they have more average kinetic energy, and cold particles move slower, they have less average kinetic energy. Potential energy is the energy used to hold the molecules together. They are very similar to an intermolecular force. Potential energy is what's used to keep the particles apart. So the higher potential energy is actually in the gas phase than the solid. We'll need to determine the amount of potential energy needed to pull the molecules apart. We can do this by using certain equations. The heat of fusion, or capital H subscript lowercase f, when we are talking about moving between solid and liquid. So Q is the heat in joules, M is the mass in grams, and capital H lowercase f is the heat of fusion constant, which is measured in joules per gram. The heat of fusion for water is 334 joules per gram. We also have heat of vaporization when we're going between the liquid and solid forms. So Q is heat in joules, M is mass in grams, capital H sub V is the heat of vaporization constant in joules per gram, and the heat of vaporization for water is 2,260 joules per gram. Now, notice how both equations are actually the same. Q equals mH. The only difference is the subscript, F for fusion and V for vaporization.